why don't we do that then? We're going to go here to the course page just to show you what's going on today. We're here in lesson number 4. And most of what we're going to talk about today is related to functions. And functions are probably among the most useful and powerful things that you can take advantage of when using programming languages like Python. And one of the really good ways in which you can try to teach yourself to reuse the code that you write. So when you produce something useful and save it in the form of a function, you make it really easy to reuse. And this is something that people who do programming for their career do all the time. It's something that most beginner programmers and natural scientists don't necessarily do. So you'll learn a little bit today of like what is a function, how to make them, and how to save them in a way that makes them easy to reuse. And then we'll talk about modules. We've already used modules a little bit with loading the math module, for instance, but we'll clarify a little bit of what those modules are. They're related to functions, and at the end, if we have time, we'll talk about writing Python scripts, and we'll actually encounter this in the lesson on functions as well. So,
and we will actually introduce you what is a script.
Yeah. But we can start here with the general concept of functions, and what I'm going to do is I'm going to launch a binder window here, and I would encourage you to either do that or launch one of the CSC notebook so that you can follow along with the lesson. All right. So yeah, if you're having trouble with binder or anything, again, you can let us know, but otherwise we're going to the L4 directory, and we're going to start with the Jupyter notebook about functions. So maybe a useful place to start just while you're getting your binder up and running is just to tell you what a function is and what it does. And essentially, it's a piece of code that allows you to easily do some kind of simple calculation. And it's a block of code that's meant to be easy to reuse. So for example, you can do things like the sine function in the math module, which will just calculate the sine of some value that you provide to it. It's a fairly simple little piece of code that just, when you use it, calculates that value and returns that value back when you use that function. We've seen other functions like the print function, and probably you already know how that one works. But the general idea here is that if we can try to push you to start writing with functions from the very beginning in terms of generating a little bit more sophisticated Python code, you'll save yourself a lot of time down the road, because once you've created a function, it's very easy to keep that around and reuse it. So if you, for instance, did some calculator of converting temperature, you write it one time, and then if you want to use it years down the road, you have it available, and it's easy to use. Now, in terms of how we create functions, we're going to talk about the anatomy of a function, I suppose, and we're going to do that in the context of this example from all the way back in the either first or second lecture about converting temperatures from Celsius to Fahrenheit to help people who might not be familiar with temperatures in Celsius. So when we want to create a function, I'm just going to go here to this first Python cell and type def, D-E-F. That's the statement that indicates we're going to define a function, and then after that we give the name of the function. In this case, we're going to call it Celsius to far, F-A-H-R, so Celsius to Fahrenheit. So that's the name that we're going to use, and then you put in parentheses the values or the parameters that you need to give to that function in order to use it. So for instance here, you might think we're going to want to give something like a temperature in Celsius. This is just a name, so it doesn't really matter. You could call it, dog food or something like that, but you, again, should probably choose something that makes a bit of sense. So here, we know the input value is going to be a temperature, or should be a temperature in Celsius. So we have def, the name of the function, the name of the value that the function uses to do its calculation, and then just like with conditional statements or for loops, you end with a colon at the end of the line. And so when I hit enter in the Jupyter notebook, it knows that I'm defining a function, automatically indents underneath that. So very, very similar to how conditional statements and for loops work as well. And here, now we're going to add one more new thing called a return statement. This indicates that when you use the function, the value that follows return is what should be given back to the user when the function is used. So in this case, we're going to return 9 divided by 5 times the temperature in Celsius plus 32. So this is, if you happen to remember, the conversion between temperature in Celsius to temperature in Fahrenheit. So we multiply by 9/5 and then add 32 degrees. So when someone uses this function, this is the calculation that's going to be used or done using the input value temp Celsius and given back to the user. So you can see here in the kind of picture below basically the things we've talked about, this def keyword that indicates we're starting to define a function, its name, the value or parameter that's given, the return statement, and the value that should be returned. So I'm just going to hit Shift Enter to run that cell, and you can see that you don't get any output. What we've done is we've created this function, and it's now stored in memory, and it's available for us to use in the future. But we haven't actually done anything here. We've just created the function, so it's like it's ready to go, but we haven't actually given it any information. We haven't given it a temperature to calculate.
So you have created the tool, but you haven't yet used it.
Yeah. So is that clear so far? Yeah? All right. So if we go down to the section on calling functions, we can now use our function and see how it works. So we could do something like this and say, let's calculate the freezing point or freezing temperature. And we'll say freezing point equals the name of our function, Celsius to var, of some temperature. And in this case, since it's a temperature in Celsius, and we know water freezes at 0 Celsius, we can put in 0 there and run that cell. Again, we don't get any output because all we've done is define a value here for freezing point. But now we can print that out with some nice print statement like the freezing point. Oops. Freezing point of water in Fahrenheit is, and then we'll put a comma, and then we'll put our value we just defined called freezing point. So this should display the text and then show what the value is that we calculated using our function Celsius to var. And if I hit Shift Enter here, indeed we see the freezing point of water in Fahrenheit is 32 degrees, and that is correct. So we did here an example where we defined the value in the first cell and then printed it in the one beneath. We can also just skip that step and do something like print the boiling point of water in Fahrenheit. And you don't have to necessarily type all of this out. You can just put the boiling point if you don't want to have a long text thing to type in here. But we can use our function even within here. So Celsius to var. And now we know, again, that we should have 100 degrees Celsius for the boiling temperature of water. So in this case, we're just putting the function inside the print statement, or the print function. And again, if you run that, you get 212 degrees, which is the expected value for the boiling temperature of water in Fahrenheit. So I guess you get the general idea here how this works, right? We made our little recipe for how we're going to calculate the value when we define the function, and then we give it some ingredients, and out comes the expected output. So yeah, I mean, we'll practice a little bit more with this, but that's the general concept. We have this reusable thing now where if we want to calculate temperature in Fahrenheit from any temperature in Celsius, we have an easy way to do that, and it's a reusable thing, so it's very simple to repeat that calculation rather than having to type in 9/5 times temp plus 32 every time we want to calculate a temperature in Fahrenheit. All right, so let's make another one here. And another useful conversion you can do is to convert from kelvins to degrees Celsius. And so we can make a new function to do that. And we'll again start with the def statement, right? We're going to define a function. We'll call this one kelvins to Celsius. So again, that's the name of the function that we're going to be using. And this should accept a temp in kelvins. So that's the name of the parameter, or the value that you're going to calculate or use to do your calculation. Again, end the line with a colon. And here, the return statement. So the value that will be given back when you do the calculation will be temp kelvins minus 273.15. So that's just our conversion factor between Celsius and kelvins. So temperature in absolute temperature in kelvins minus 273 gives us the temperature in Celsius, okay? So if you shift run or shift enter to run that cell, or press play up at the top if you're a kind of mouse-oriented person, we can test it out, right? So we should figure out first, let's go with absolute 0. So absolute 0 is equal to our function name, kelvins, to Celsius. And just to show you another way you can do defining of the parameter in one of these functions, we can actually give the name, if we know the name of the value that's expected to be here, we could say something like temp kelvins equals 0. Now, it doesn't necessarily make a lot of sense to do that when you have a single parameter, but you can have multiple parameters in a function. So you could have 3 or 4 values that are listed when you call the function. And when you start doing that, it can be nice to name each of them separately when you call the function, so that it's clear to you as the user which one of the values is given which number value or text value or whatever, which one of the parameters is connected to each one of the values. I don't know that you necessarily have to name them, but if you don't name them, I think you have to know the order in which they're...
The parameters.
Yeah. If you have multiple parameters.
Yeah, not necessary, but it might become difficult to actually use the function.
Yeah.
So,
So this is just kind of a toy example here by putting temp kelvins equals 0 just to kind of show how it works. But if you run that, again, you don't get any output, but we can add our print statement here and say that absolute 0 in Celsius is, comma, absolute 0. And again, if you hit, if you spell your variable name correctly, absolute 0, not absolute 0, you should hit Shift Enter and see that you get something like minus 273.15. That's not really a big surprise. 0 minus 273.15 is minus 273.15. So yeah, I think I'm going to maybe go off the script for just a second here and show that there are some other things you can do here in terms of speeding up the input. So if you add another, you just hit the plus button up here, add another Python cell down here. When we did our absolute 0 definition, you know, you have to type that name in to store some value with it. But if you then say it's equal to, and start typing in this name of the function Kelvins to Celsius, you can hit tab, the tabulator key over on the left side of the keyboard, and it will auto-complete the name of the function if it is a unique first set of characters there. If you have another variable named Kelvins to Celsius, it will then pull up a little list and you can choose, or something similar that starts with Kelvins, you can choose how you want to complete that, the input for that line. But you can hit tab in some of these cases and speed things up a little bit in terms of the input. In fact, it's even nice that if you have, we won't necessarily show how to do it today, but you can add documentation to these functions as well, and that's even available so that you can see how they work. If you use some other functions, maybe with the modules, we can see if we can show an example of how that works in the second part of the lesson. But you can also, I think, if I'm not mistaken, if you start typing in the name of one of the parameters inside the function, Python, or IPython at least, that's running in the background of these Jupyter notebooks, it knows what the names of the parameters are. So I can hit T, and now I hit tab. It gives me some different possibilities of how I could try to complete this, because it doesn't know, am I typing in temp kelvins, or am I typing in try, or something else. But I see temp kelvins is there, and I can hit enter and then put in a value. So if you're just wanting to kind of type things in a little bit more efficiently, the tab key pretty much will never do anything nasty. And at best, it will either auto-complete things or give you some prompt for how you want to finish the line, or what you're typing in. So people who work in these Jupyter notebooks or coding in Python, or even in the kind of command line interface in Linux, for example, use the tab key all the time, because it's just a big time saver, especially if you have longer function names and things like that.
Yeah. I wonder, maybe we could improvise a bit at this point. You could, now the ones who have no Jupyter Lab open already, we could take a short practice for a few minutes. So there is also a possibility, now we have only passed one parameter inside a function. But let's, you can also pass multiple parameters. So let's do such a function like repeating the things that we did in the really first week. So let's just create a function called hello, and let's add two parameters to that function. One would be name, so the idea is that hello your name, and the other one could be like, no, let's do so that hello I am, and then the name, and I am X years old. So you would have two parameters, one would be the name and one would be the age. and then the function should basically return a print statement, hello, I am X years old. So let's take a few.
Let's maybe just put the instructions down here for a second. So create a new function called hello with 2 parameters.
Yeah.
Parameter 1 should be called name, and you should provide some text for this. So when you use the function, and parameter 2 should be called, what did you say, age?
Yeah.
And you should provide a number value for this when using the function. And if we just say example output, oops, let's say hello, Dave. What did you? I can't remember what you were saying.
I am X.
I am. I'll be honest. 38 years old.
Yeah, something like that.
So should do something like this. Yeah.
So basically the idea, like how do you define multiple parameters is in a similar manner as when printing multiple variables. So you basically separate those variable names with comma, and that's it. So inside the parentheses you can specify as many parameters as you want.
Yeah. So yeah, go ahead and see what you can do with that. We'll come around and check in and see how things are going, and then maybe continue in just a few minutes.
Yeah.
As is the case with this kind of activity, I'm not exactly sure that I'm going to get it right the first time around. So this will be fun. So yeah, we were told that we need to define a function named hello. So we can start with the def statement. The name of the function in this case is hello. And it should have 2 parameters.
Name.
Yeah, no, I know that part. Do we mention anything about default values and parameters in functions?
No, we didn't yet. Maybe we could. Or
well, let's keep it simple for right now. So we need 2 things. We need something called name and something called age. Those were the 2 parameters that were we were told that we should have in the function. And I guess probably most of you got this far. So far so good. Now, when it comes time to return, things are a little bit more complicated here. We're not going to use the print statement directly here, but rather return a string or character string that we can then print out. So in this case, we're going to return, hello, my name is, and then I'm going to do this with just the kind of simple concatenation or adding together of character strings that you can do in Python. So my name is plus name, because name is going to be a character string value. We don't need to put in any tests in our function to check and see whether the user actually provided a character string, but we're going to assume that the user does that. And so my name is name and plus, And I'll just continue with the other parts that should be here. So there should be a period, I am. So then I can put I am, and then I'll include again the space here, another plus. And now we've got this number value in here, and you might remember from before that you can't add together numbers with character strings in Python because they are not of the same data type and they're not compatible with one another. Does anybody remember how we handle that problem? Yeah, right? So we have to use some type conversion thing here. In this case, we're going to use the string or str function that will create a character string from whatever the input number is. And inside that, we're going to put age. So that'll convert our age to be some character value that can then just be added to the rest of our string. And we'll continue on here with the space, years, old, and a period. So this is actually not necessarily a trivial example to do as a function because what you return in the return statement is kind of a bit more complicated than you might think at first. But basically all it is just a bunch of character string pieces that are glued together. So hello, my name is something that we're just going to type in ourselves here. Whatever the user supplies as the name will get substituted in at this point, and then I am, and again we'll do substitution for whatever the value for age is when this function is used. And so I'm going to hit Shift, Enter, and
I have no kernel.
No kernel. No. Okay. I'm just going to click up here. If that's happened to you, if you're using Binder, sometimes the kernel dies. You can just click up at the top, and I just chose Python 3. Okay, so now that the kernel is running, I've defined the function called hello, and just as before, we've defined it, but we haven't used it. So let's use it now, and print hello, and then we're going to give it some variables. And remember the first one should be name equals, and we'll put in Dave in this case for me, and age equals 38. That can be a numerical value. We could have written the function differently to expect that the number, the age would be a character string, but this is what we have. So we've got the print, and I'm just going to add a space here just to make this easier to read. And then we're calling our function called hello with this name and that age, and it works. So that's just a sort of on-the-fly example. We can add this to the lesson materials just so that you can see the example there. In fact, we'll add it with the solution so you can see the function just like what we've done here. I'm in Binder, so I can't easily save this right now, but after we're finished today, we can add that in case you're still not quite sure how you would do this yourself. But could I ask at this point, are there any questions?
So there are a few key things. You need to define the function starting with def keyword, then you have some name, then you need to have some parameters that you pass or that you use to pass information inside the function, and then you return something. And when you have defined the function, then it doesn't do anything yet, so actually getting some output from there, you need to use it by calling it. So those are kind of the key things.
Yeah. Yeah.
Just asking, is that on the print statement, is the name equals and age equals necessary?
So, I don't know actually if these are needed. I think as long as you put things in the right order, it should work just like this.
Yeah.
Yeah.
It should work. The thing with using the keywords there, like the parameter name, so name equals to something, that's good in a way because if you use those keywords that you say that, okay, this parameter, the value for that is this, for example, name equals to your name and the age equals to something else, then it actually doesn't matter in which order you pass those parameters into the function.
Yeah, so if we flip these around, for example, we have problems because now it doesn't know which one of the parameters. Well, it tries to put in 38 for the name and Dave for the age. If I said, for instance, now age equals 38 and name equals Dave, I can run that and that works just fine in any order. So in some sense, this is better not only for reasons like Henko was saying in terms of clarity, but you also don't need to remember the order in which the parameters are given in the function, which I wouldn't suggest that you have functions with like 15 parameters, but sometimes you'll encounter functions that have a lot of parameters, like in Matplotlib, the plotting library that we'll see later in the course. There's some plot functions that have 10, 20 different things you could pass to them, and you have to name them. Otherwise, good luck trying to kind of keep them straight in your head. I don't think it's not possible for someone like me. Okay, so that was a little bit of a sort of deviation from where we were going, but that was a good thing because I think hopefully it's good to kind of make yourself have to try and create your own function at this stage already. We're gonna just move forward with a couple things before we take our break in a little bit. But the first of those things is we've created these functions. If you can remember back to like the start of the lesson on functions not so long ago, we created the function for converting Kelvins to Celsius and converting Celsius to Fahrenheit. We have those two functions that exist. Since those have been defined, we can define a third function that actually uses those within it. So that's what we're going to do here. And let's just start like we should with any function with a define or def statement. And we're going to call this one Kelvins to, and I'm just going to call it far. It's Fahrenheit in the lesson online, but we're just going to cut that a little short. So Kelvins to Fahrenheit, or Kelvins to far, and it's going to get one parameter, and that is a temp in Kelvins. So just like we had before when we converted Kelvins to Celsius, temp Kelvins is the name of the parameter that should be given to this function. Okay. So what should it do? Well, first, we're going to convert Kelvins to Celsius. So we're going to define a variable inside the function called temp Celsius. And we'll say that's going to be equal to Kelvins to Celsius. I'm going to hit tab here. Oops, it gave me Kelvins to far. Okay. We got one thing we're going to have to deal with here. And that is because my kernel died, I lost my Kelvins to Celsius function I defined earlier. So let's finish typing this in. So Kelvins to Celsius is the name of the function we defined earlier, and it took a value in Kelvins, converted that to a value of temperature in Celsius. So that's what we're going to do here, just using the earlier function. We can also now define something called temp far and do something similar where we convert Celsius to far, and the parameter that we're going to give this, or the value we're going to give it, is temp Celsius. So I'm just going to copy and paste that in here. So we've defined the function. We've got temp Celsius being equal to Kelvins to Celsius of temp Kelvins. And then we've got temp var being equal to Celsius to var of temp Celsius. We defined those two functions earlier, so we can use them within this function. Then the idea would be that the return value would be temp var. Right? We want to return the temperature in Fahrenheit. That's the idea when we go from Kelvins to Fahrenheit. We could convert directly from Kelvins to Fahrenheit, but that conversion factor is not something that I happen to know directly. I mean, we could do that, but since we've already defined these other functions, let's just use those. We know they work. We can test them with known values and we get back what we expect, so we should be okay, because I don't happen to know, for instance, what absolute zero in Fahrenheit is, but I know the freezing temperature in Fahrenheit, the boiling temperature in Fahrenheit, and some other things that I can easily test in these other functions. So if your kernel died like mine did, when you hit Shift Enter or the play button on this cell, you're going to get some bad news. Okay, you should have gotten some bad news. I don't know why that worked. That's mysterious, because I think
you run those already, though?
Well, I did earlier, but then the kernel died, so I don't know why those would still be defined. I'm just going to scroll back up to be safe and run the cell. Okay, hold on. There's something not quite. Oh, yeah,
It seemed that they were.
It did seem like it worked. Okay. Well, all right. So if that is indeed the case, we can then test out our function, our Kelvins to var, by doing absolute 0 in Fahrenheit, F-A-H-R, or F, I guess, equals Kelvins to var of temp Kelvins equals 0. So again, I'm hitting tab inside the parentheses of this Kelvins to var function just to speed up the input. So this ought to define our value of absolute 0 in Fahrenheit. So I run that cell, and then we can, just as we did before, print out something that says absolute 0 in Fahrenheit is, and then absolute 0. So I know I'm typing quickly, but you could just, if you want, just print out absolute 0 F if you just want to see if the function works, but we'll give it some nice output. And so when I run this using the Kelvins to var function that we've just defined, I get this value of minus 459.669999, blah, blah, blah. I don't know if that's the right value, but I assume it's right because the other two pieces of the code we tested with values that we knew. So, and I'm sure if we wanted to look up what the temperature of absolute 0 in Fahrenheit is, we could go on Wikipedia or something and find that pretty quickly.
So this is now basically, I hope you saw, but this kind of approach is really powerful, because that's and quite typical as well, so that you can break your code into small pieces, and then you can have this kind of functions that we just created that can cater and use those different functions in any way, or well they can have different functionalities what they do, and then you can kind of return something that is actually fairly complicated, but still those little pieces are fairly simple to understand and even fix kind of things from the functions if there are.
Yeah, question?
Yep. So in Kelvins to var, you defined that temp var variable and you returned it.
Mm-hmm.
In the earlier example, you just returned the calculation. So which would you say is the better practice or preferred practice?
I'd say it depends a little bit on like how complex the function is. If it's something really simple, you can just return the value like that's done as the calculation on one line. If the calculation is a little bit more involved, I generally like to define a variable and then return that variable just because I think it's a little bit easier to read that way. But I don't really think there's necessarily kind of a regular kind of preferred way to do that.
Typically how I do, so if it's really trivial function, like I have some sum function that has to take two numbers and sums them together, then typically I just return directly like what is the like number 1 plus number 2. But when you kind of have a bit more complicated thing as you mentioned, so then it might be good to actually have something that clearly states what it does and do it kind of separately there. The main idea is that what we are aiming at is to be as clear as possible, so that when someone else reads your code, he or she understands what it is doing.
Mm-hmm. So the one thing we haven't mentioned, or one of the things we haven't mentioned about functions yet, is that when you're dealing with functions like this and we define these variables inside the function, they don't exist once you exit out of the function. So they're not stored in memory. So for instance, something like tempvar, we haven't defined that anyplace else except inside this function when we've used it. And if I was, for example, just to add another Python cell down here beneath where we printed out absolute 0 and just wanted to print out what the value of temp var is, it says it's not defined. This is among the things that are confusing for new Python programmers when they start using functions. This idea that, well, wait, no, I defined a variable inside here called tempvar. How come I don't have the value when I come out? I even returned that value. But when you return that value, the return gets assigned to some other variable name. Tempvar, temp Celsius, the values that are used within the function are just temporarily used when the function is doing its calculations, and then after that they're gone.
Yeah.
So
they only live inside the function, not they don't do anything outside.
Yeah. And what's even more confusing in some respects is that you could have a variable name that's the same as something that's used inside one of these functions. So let's do this as an example. I'll add again another Python cell here, and let's define a variable called tempvar. And let's say it's equal to 32 degrees. Okay, and we define that, and then I'm going to copy and paste this absolute 0 f thing up here. When we called our function before, we know we return a variable called tempvar from within the function, and we define its value here inside the function. And if I print out tempvar at this stage before I call the function, and then print it out after I call the function, this will be a little confusing because it's going to be 3 lines of output or 2 lines of output. But I'm just going to run the cell, and I see that I have 32 and 32 both for the variable called tempvar before and after the function. I could take something like temp Kelvins and give it a different name, and well, let's do it just because I think it's important to sort of see this. So if we add another Python cell down below here, and if you don't want to type all this in, you don't necessarily have to, because I know probably going a bit quick. But we know here that inside the function we have this variable called temp Kelvins, this parameter called temp Kelvins. So let's set that equal to some gigantic number. All right, and we print out what the value of temp Kelvins is. Then I'm just going to, again, copy this where instead of saying temp Kelvins equals 0, I'm just going to put in 0 for the Kelvins defer function, which essentially is setting temp Kelvins equal to 0 as a parameter for the function. And if I print that out, the value of temp Kelvins after I use the function, I get this whatever,
A big number.
yeah, 5 billion or something like that, both before and after. So when you use functions, things that are inside here, the parameters that you pass, they, even if they have the same name as some variable that exists elsewhere outside of the function, it will not conflict with the variable name outside of the function. And if you think about this, it actually makes a lot of sense because you don't necessarily know the names of the different parameters that are defined inside functions that you're going to be using if you use some like math library or something like that. The math library could name functions all different kinds of things that might conflict with other variable names that you're using in your code, like tempvar and or temp Kelvins, for example. And even if you have something like in here where you say temp Kelvins equals 0, that's only defining temp Kelvins inside the function. So it doesn't replace the value that was defined in the rest of your script. And so, yeah, if you use temp Kelvins in your script and you use some function that just happened to also use a variable with the same name as a parameter, you don't have to worry that those two things are going to overwrite one another. And that's this, the kind of reason why that stuff only exists as temporary variables inside the use of the function, and then you can't get the values back outside. Does that make sense? Kind of, yeah.
Yeah.
Does it work the other way? Does it take the temp Kelvins if you don't have any definitions inside those lines? So if you take the 0 out, does it take that?
No. So if we don't give anything inside here, it gives us an error message saying that we're missing a parameter. So it says one required positional argument, temp Kelvins is missing.
But if you just write temp Kelvins,
Yeah.
So if we wrote temp Kelvins inside here, it would take the variable value called temp Kelvins and assign that inside the function. So that would work to do that. Now I've stored its output as absolute 0f. And so, temp Kelvins, nothing actually happens in terms of the calculation that's done to the value of temp Kelvins.
But that's a good point because this is exactly why, really typical case how you are using functions. So typically you have something stored in some variable and then you pass that value inside the function and return something and continue doing something else.
Yeah. But yeah, so I mean that's exactly right. It very often is the case that the variable that you pass in happens to have the same name as some parameter in the function. But so you could even say something weird like temp Kelvins equals temp Kelvins, which looks like it would come back as either like a true or false type statement, but the function distinguishes between the variable that exists in the kind of Python world on the outside and then the fact that you're assigning that to some local variable inside the function.
Yeah. But these are kind of nuances of different things related to functions, and you are most likely going to learn yourself after wondering why does something work as they do when you do the programming. So don't worry too much about it.
Yeah, and I think part of the reason why we're kind of moving slowly through the functions, in part because this is something that's caused a lot of confusion in the past, and frankly, some of the other things that we need to cover are less confusing, and you could even just read the lesson materials on the web page, I think, for like modules, and wouldn't have any problem understanding how those are used. So can I ask, are there other questions about functions at this point? because this would maybe be a good place to take a pause, and then we can continue on to using script files. We're not super far through this functions lesson, but frankly, if this is the only thing we do today, that's not really a problem. So.